Welcome. In this video, we will discuss direction fields and their relationship to differential equations. Direction fields give us a way of visualizing the general solution for certain differential equations. The differential equations that are applicable in this section are differential equations of the form dy dx equals some function of x and y. We could also use y prime instead of dy dx. So these are first-order differential equations where the first derivative of y with respect to x is expressed in terms of x and y. Now, before we talk about how to generate a direction field, we need to review an important concept about derivatives. Remember that the derivative at a point is the slope of the tangent line at that point. Now, to create a slope field, we consider a bunch of sample points in the xy plane, and at each point, we will sketch a short line segment with a given slope. The slope is given by y prime, because y prime is the slope of the tangent line, and the way to find y prime is to plug the values of the point into the expression for the differential equation. Let's see how to do this with a specific example. We have a differential equation y prime equals x plus y. This is the function f of x, y. We want to create the slope field, which we do by taking a sampling of points in the plane, and at each point, we plug the x and y values into the differential equation and sketch a small line segment having that slope. For instance, at 0, 0, we have x equals 0, y equals 0. Plug those into the function here, and we have 0. So we sketch a short line segment with a slope of 0. At 1, 1, we have 1 plus 1 equals 2. So we sketch a short line segment with a slope of approximately 2. At 0, 1, we plug in 0 and 1 for x and y. 0 plus 1 is 1, so we sketch a short line segment having a slope of 1. We do the same thing for any number of points that we choose in the plane until we have a picture of this slope field. We could take some more sample points here. If we take x equals negative 1, y equals 1, we get 0. If we take x equals 2, y equals 1, we have 1 plus 2 is 3. And we can imagine generating many more of these sample line segments. This is tedious to do by hand, so we like to rely on computer graphing systems to do this for us. Here is the slope field for the differential equation x plus y. All of these small line segments are generated by taking the specific points that they pass through, plugging them into the differential equation, and getting a slope, which is the slope of each line segment. This slope field allows us to visualize the general solution to the given differential equation. If we take a specific point and follow the direction of these line segments, we will get a graph. For instance, let's draw the solution curve that passes through the point 1, 1. We start at the point 1, 1, and then we follow the direction that these line segments point us. So this curve would go up something like this, following the direction of these line segments, and then it would go something like this. This is one specific solution to this given differential equation, and we can visualize this by following the direction that these little line segments point us in. Let's try another example. Let's try sketching the solution curve that passes through the point 0, negative 2. Here's the point 0, negative 2, and once again, we follow the direction that these line segments point us in. The curve would look something like this. These two curves are two specific solutions to the differential equation. We could visualize any specific solution passing through any point that we want using this slope field. Let's take a look at this in Desmos. Here we have our slope field once again, and we have this point, and at each value in the xy plane, the slope for this small line segment is x plus y. Let's take a look at some specific solution curves again. We can move this point around, and the solution curve passes through that point. We can visualize various possible solution curves that follow the slope field for this differential equation.